Find the power set of the empty set. Now we have to ask the question, are there any subsets of the empty set? And the answer is yes. There is the empty set. The empty set is a subset of every set, including the empty set itself. And the reason why the empty set is a subset of every set is because to be a subset means that everything in the first set has to be in the second set. But that's an if-then statement. To be a subset means that you have to satisfy an if-then statement. But if the if part of an if-then statement is false, which it is under the empty set, then the whole implication is true. And that's because on a truth table, if you look at P implies Q is actually true when P is false. And so therefore the empty set is a subset of every set. This is vacuously true. So this power set is going to contain one element. It's going to contain one subset, which is the empty set. Now keep in mind the power set always contains the empty set, but it also contains the whole set itself and everything in between. But the whole set here is the empty set. And we can't list the same element twice in a set. So really there's just one element here, the empty set. Now we have to take the power set of the empty set. But that's just the power set of what we got from the last answer. So this is the power set of the set containing the empty set. Now it's super important to understand the distinction between part A and part B. You might think part A and part B are the same. And if you do, let me clarify something. Part A, you're taking the power set of a set containing 0 objects. In part B, you're taking the power set of a set containing 1 element. That's the key distinction between part A and part B. Part B, we're taking the power set of a set containing 1 element. Now, that element in and of itself is the empty set, and that empty set doesn't contain any elements. But the empty set can be considered an element in and of itself. And that's why the set containing the empty set is not the same thing as the empty set. The set containing the empty set has something. It has an element. It has the element, the empty set. Even though that element doesn't have elements in and of itself, the empty set can be considered an element. And so let's talk about the power set again. The power set is the set of all subsets. In this case, we're trying to find all of the subsets of the set containing the empty set. Now keep in mind that the empty set itself is a subset of every set, including this set here. But moreover, we can take the whole set itself, the set containing the empty set. Keep in mind that every set is a subset of itself. Now you might ask the question, aren't these the same? And again, I really want to stress the first element here has no elements. The second element here has 1 element. And that's why they are different things. And so I'm listing 2 different things here. So the power set of the empty set has 2 elements. For part C, we have to take the power set of the power set of the power set of the empty set, which is really just the power set of the result from our last problem. Now we're taking the power set of a set containing 2 elements. The first subset is going to be the empty set. Now we have to think about all of the other subsets of this set containing 2 elements. Either we can have a set containing the first element, a set containing the second element, or the set containing both elements, which is the whole set itself. And so that means we can have the set containing the first element, or the set containing the second element, which this is going to look a little weird because it's the set containing the empty set, or we can have the whole set itself containing both elements. And that is the power set of the power set of the power set of the empty set. And it's really important to understand the difference between all 4 of these sets. If you think conceptually, like, it's really easy to confound these elements and think that they're all just collections of nothing, but they're not collections of nothing. The only collection of nothing here is the first element. The other elements actually have things inside of their sets. So the second subset has an element. It has the element, the empty set. So the empty set is considered an element here. This set here contains the element. In this set, the element is the set containing the empty set, which is different from the previous element, which is just the set containing the empty set. They sound similar, but there is a huge distinction. In this case, the empty set is considered an element in and of itself. In this case, however, the set containing the empty set, the element of this set is a set containing the empty set, which in part B we clarified is not the same thing as the empty set. And so therefore, the set containing the empty set is not the same thing as the set containing the empty set. And then the whole set itself is a subset of itself. And that's a property of all sets. Every set is a subset of itself. And so we have the empty set and we have the entire set and everything in between. And that's how you do the power set of the power set of the power set of the empty set. Thanks, everyone, and I'll see you in the next video.